Hello dear students, I am Professor Mandar Dikshit from Electrical Engineering Department. Today we will solve one more problem based on RMS value calculation of sinusoidal wave. Let us take an example. The example states that find the RMS value of the waveform shown in the following diagram. This is the waveform given for our problem. If you observe the waveform, it is sinusoidal waveform. Then also it has two halves, that is positive half and negative half. For positive half, from 0 to pi by 6, the waveform has 0 value. At pi by 6, it starts increasing and behaves as a sinusoidal waveform. Again, in negative half, before 2 pi, that is becoming 0, it again before it becomes 0 and further continues up till, in both positive and negative halves, for some interval the waveform is becoming 0. Hence, this waveform is symmetrical waveform. The value at which it becomes 0 is 50% of maximum value in positive direction and 50% of maximum value in negative direction. Hence, the waveform can be considered to be symmetrical waveform. Now, the RMS value of a symmetrical waveform can be calculated as considering only half cycle. As it is a symmetrical, so both values will be same. Hence, we will consider only half cycle of the waveform. Let us solve the problem. Now, we are considering only half cycle. So, our period or interval of waveform is 0 to pi for half cycle. Because of behavior of waveform, the half cycle can be splitted into two intervals. One is from 0 to pi by 6. And second will be from pi by 6 to pi. Let us write down this interval. So, first interval is 0 to theta to pi by 6. So, that means theta varies from 0 to pi by 6. During this interval, the value of voltage is 0 from 0 to pi by 6. From pi by 6 to pi, that will be second interval. From pi by 6 to pi, the waveform is behaving as sine waveform. Hence, the equation of voltage during this period is V is equal to Vm sine theta, which is the waveform equation of standard sinusoidal waveform. Now let us calculate the Vrms value. For half cycle, the RMS value can be calculated by formula square root of area of half squared wave divided by base length of half squared wave. From our waveform, we can write down as area of half squared wave. Area can be calculated by integration with half cycle of 0 to pi. The squared wave is V square and integration with respect to d theta. The base length of half squared wave, that is interval of half cycle, which is pi. Hence, our equation for the given waveform is Vrms is equal to square root of 0 to pi V square d theta divided by base length of half squared wave is pi. We have divided the half square wave into two intervals. Let us put that intervals. Let us simplify the equation by squaring both sides. So we will get Vrms square is equal to 1 by pi integration 0 to pi v square d theta. We have splitted the given waveform of half cycle into two intervals. Let us substitute that intervals. First interval is 0 to pi by 6. And second interval is pi by 6 to pi. So this is our first interval 0 to pi by 6 v square d theta plus pi by 6 to pi v square d theta, that is my second interval. We have the value of v square for particular interval. Let us substitute that. For first interval the value is 0. For second interval value of v is Vm sin theta. Again simplify. Further simplify, we will get the first part will be neglected because it is 0. So second part will be as it is. Take Vm square outside, so it becomes Vm square by pi. In bracket we have substitute sin square theta as 1 minus cos 2 theta divided by 2. So take 2 outside, Vm square by 2 pi. Then let us write down the integration of 1 minus cos 2 theta. Integration of 1 is theta minus integration of cos 2 theta is sin 2 theta divided by 2. Intervals pi by 6 to pi. Substitute the values of intervals. For first it will be upper limit minus lower limit, that is pi minus pi by 6 minus substituting value of pi by 6 sin 2 pi by 2, we will get finally I will get Vrms square is equal to 0.48 or Vrms is equal to 0.697 Vm, which is our answer of the numerical. So for given waveform, Vrms is equal to 0.697 Vm. That is RMS value of given waveform in the problem. Thank you for watching this video.